Is my screen visible? Is there anybody
Yes, sir.
who is not able to view that screen? Okay. Subject that I'm going to teach you is engineering mechanics. From the term itself, you can get what this subject may be regarding. It's quite a mechanical part of the engineering objects or engineering phenomena or the mechanisms that actually arise in what engineering structures. Fine. Firstly, what we have five chapters, as you already know, in this course. The first one is your force system, and from force system, definitely you will be able to evaluate uh, what a force is actually, and you already have a concept what a force is, and how we evaluate that force, and what are the reaction components that a force needs to evaluate on the basis of its direction, on the basis of its magnitude, and so on and so forth. In this chapter, uh, and then we have second chapter, in which we will be talking about centroid and second movement of area. I guess second as well. And the third chapter is basic structural analysis. I find this more important one because in your future you will be having number of courses with regard to this structural analysis. You will be having structure analysis 1, you will be having structure analysis 2, you will be having advanced structure analysis. So here the foundation understanding of this foundation unit is quite important to all of you. And then the chapter fourth is center of gravity and moment of inertia. Again, you have some concept regarding center of gravity, and you also have some concept regarding moment of inertia as well, and its implications, and the way we calculate a different moment of inertias and different center of gravities for different structural elements, whether that be a cone, cylinder, or whatsoever is there. You have some concept how we can actually calculate the moment of inertia for any member. And then finally, we have fundamentals of dynamics. Fine. Fundamental from the term itself, fundamental of dynamics. Dynamics means what? When any of the structure is loaded, which and that loading is getting changed with respect to time. That means dynamic. That's a dynamic loading. Fine. And we have two types of loading. One is static loading, and another is dynamic loading. Static is it does not change with respect to the time, and dynamic is changed with respect to the time, and so on and so forth. We will try to understand it once we reach to this last and fifth chapter. Now, firstly, we'll be checking out what is with regard to our chapter number one or unit number one. What is it all about? Now, your unit one, as the name itself says, that this chapter is primarily it says with respect to what the force systems, what kind of forces can come on the on any object, and how to evaluate. Evaluation is what? Evaluation is basically the response, right? Evaluation is the response of any structure. How will it respond to the external loads? And that understanding that system is called as force system. Now, this is your unit one force system. Now, it basically has what? It has certain things which we have to study. Primarily, the primary things are the concepts that are behind this force system, right? And then we need to understand the equilibrium of rigid bodies, right? We need to understand how the equilibrium is attained in the bodies. Fine. And then we also have to understand the system of forces. What different types of forces can be there? What is the system that is in between the force system? And then we have different types of forces, which we called as coplanar and concurrent forces. And all we will be studying about the resultants, as you might be having some concepts. If you have two forces in two different directions, then we calculate the resultants as well. And then we also have to study about the movement of forces and its application. Movement, you know what is a movement also. And then there is a couple and resultant of force system which we have to study. And one more term which is called as free body diagram. What is that free body diagram? Right? We will be studying that as well. And we will be studying one important topic, which is equation of equilibrium of coplanar system and special systems. Finally, we will be ending this chapter with static indeterminacy. What is static indeterminacy and what is static determinacy? We'll be solving few problems regarding many structural elements, and we will be evaluating them whether they are statically indeterminate or statically determinate. Okay. Now here is the first thing that we need to understand here. As this first chapter is not that numerical portion which you need to understand. It is about the definitions or the systems that we need to understand. So you will have to pay attention, and you will have to read them three times once you complete this. What does this mean actually? Firstly, the force system. Name itself, force system. It defines basically what? It defines collection of forces, because on any subject there can be number of forces. If there is an external force, for example, on any normal body, because of that external forces will be there, it will be having reactions, it will be having internal forces, it will be having internal stresses. So understand, and there will be number of forces, there will be a collection specified location, and thus the set of forces shown on any free body diagram makes up a force system. Okay, set of forces. For example, if you have a normal beam, you will tend to find out what are the different types of forces that can act upon on any free body diagram. And from the free body diagram you actually present the number of forces, which include the reaction as well, because it must be resting on ground, it must be resting on something, and that something will provide what? That will provide reaction, and that reactive force is also a force system. And from the force system also, it's simply term used to describe a group of forces. Okay, what is force system? It is simple. In simple terms you can memorize it this way: a group of forces. Fine, a group of forces that can be external as well as internal forces. Now, when two or more forces or movements are combined, then that is called as resultant. Fine. When two or more forces or movements are combined, when you have three, four types of forces coming on a body, then what you say, the combination of that forces, you describe that term as a resultant. A resultant of what? A resultant of different types of forces acting on any specified location of the body. Right? Now, this is your force system. Now, force. Can anybody tell me what is a force? Can anybody participate in the conversation and tell me what is a force? Anybody? Anybody? Okay, CR, can you tell me what is a force? Are you able to hear me?
Sir, a push or pull. Sir, a push or pull is known as force.
So that is the simplest form, push or pull. Okay, good. It is simply said that if we push any body or any member or we pull it, it implies what? Force. It is a simple force. And force is basically what? And you can also say force is the capacity to do work or cause any physical change, right? Force is what? Capacity to do any work or cause any physical change. And we also say that if we have to calculate how much amount of force is to be needed, then we say it's a mass times acceleration. Force is ma, simple. Force is mass times the mass of that object times acceleration. From here also you can see what is force. It is in simple terms, it is push or pull, or it is the capacity to do work or cause any physical change. Okay, and one more point that you need to memorize while you are evaluating force is, if you have to calculate it, it is mass times acceleration. That is F is equal to as ma, which you already know. And finally, what is actually a force? It is the thing that changes or tends to change the state of rest or motion of the body. Okay, now what do you understand with regard to force? Primarily, it is simple push or pull, or you can also say it is the capacity to do work. Work force is what? It is the capacity to do work. If that object or if that force has some capacity to do some new work or cause any physical change, that is called as force. And mathematically we can evaluate it by saying that force is mass times acceleration. And also you can say a force is that which changes or tends to change. That means after applying force it can change the state of rest or motion of the body. That is called as force. Few more points by which you can memorize or you can understand the force is here. Again, an agent which produces or tends to produce or destroys or tends to destroy motion of the body is called force. Okay, by this you can understand that if something was in motion, for example, there is a picture at the bottom. What he is trying to do, he is trying to push that big element. Okay, he is trying to push that element, and he is tending, he is putting some force, right? He is putting some force to move that object. Okay, he's tending to produce or he is tending to destroy. Now there is something which is tending to destroy that motion, right? Because if he is producing, if he is tending to move that object, he is giving some force. But there is another force which is coming again from the object. What is that force? That is a reactive force which is coming by the friction of the surface through which it has to be, through which it is tending to move this body. That is again called as force. And again, you know that we usually measure this force in terms of what? In terms of newtons. And one more point is that a force is specified by its magnitude. How do we say what amount of force is? Simply by its magnitude, and we also say its direction and its position, and is a primary thing, right? Is a primary thing. We need to understand that it is not only the force magnitude. For example, we have 10 kilonewton magnitude of force that is to be used to move any object, but in which direction? That is also to be computed. It involves magnitude, magnitude and direction both, and position. Then we can say it is simply a vector quantity, because vector quantity should have magnitude as well as direction, and it should have what? Simply line of action and direction. This is the primary fundamental of a vector quantity. Simple, it should have magnitude and as well as direction. Okay. Now, your one more thing that we need to understand here is characteristics of a force. How do we characterize it? How do we characterize? As we had already discussed earlier as well, that primarily it should have what? Magnitude. That is the characteristic of any force. It should have magnitude, it should have direction, it should be, we should know the nature of the force, which kind of a force is it. And fourthly, the point of application, the point of application of the force. Now, what does this mean? These four characteristics of a force, which you should remember always. The characteristics, for primarily, the thing is that we should know the magnitude, how much amount of force is to be applied to do any work, to tend to either move the object or tend to stop the object. Because in both the cases, we need force. Okay, first one is magnitude. As you already know, it is the low amount of load, and it is to be calculated in newtons or kilonewtons, whatever is the load. And secondly is the direction, right? It should have a certain fixed direction. If it is moving in x direction, or it's moving in xy direction, or xz direction, we should be knowing the direction in which it is actually the force is acting. That is the direction of the line of action. For example, OY, or many a times we have different angles in which the load is being applied, or the direction of the load is. So we should be knowing the line of action of the force. Okay. Thirdly, the nature. Nature is what? What kind of force are we applying? Is it a tensile force? Is it a compressive force? Are you pushing the object, or you are pulling the object? Those kind of